Thanks for coming. Let's see. Hang on. It's confused. It's all right. I'll just do this. The mouse might have confused it. If we take that out, we should have tested that after. I've just unplugged the mouse. Hang on. That's weird. Hold on. Yeah, it wasn't focused. Cool. Sorry about that. My name's Sean Collins. I'm a landscape architect from New Zealand, but I've been in London for the last 10 years, the last 3 of which have been at ACOM. I've always had a thing for computers and AutoCAD, which usually results in me looking after the day-to-day technology within the companies I'm in. Being the person tasked to finding solutions to tech issues we have, like how on earth do we deliver a BIM model for a 40-hectare site? A note before we start, I am not a civil engineer, I'm a landscape architect, and I've had no formal training on Civil 3D. There's probably better ways to do much of the modelling that we've done, and hopefully one day we'll figure them out. Just a quick show of hands, how many people here are civil engineers? And how many are landscape architects? Right. Just thought I'd ask. Just a quick outline of what we're going to look at. First, I'll just give you a brief introduction of the project, which is the Dubai Expo 2020, followed by an explanation of why we use Civil 3D and not other programs. I will then also go over the process we undertook to develop the BIM capability of Civil 3D and production of the final BIM model, given that we didn't know anything about Civil 3D. Finally, I'll show you our final model and cover the issues that we're still facing and how we're looking to overcome those. At the end, there's likely to be a lot of time, so we can have a look at the model and I can answer any questions that you have. In 2015, ACOM were contracted to deliver the stage 2, 3 and 4 packages, including a BIM model to level 3 for the Dubai Expo. The site, halfway between Dubai and Abu Dhabi, is 40 hectares. A concept had been developed up to stage 2, which we were then to resolve and prepare up to stage 4. The revised design ACOM prepared included 3 theme areas, each including a central souk topped by a theme pavilion, country pavilions and a perimeter, country pavilions to the perimeter and an arrivals plaza. At the centre, where the theme concourses meet, is a circular Al Wasl Plaza. Between the theme areas were 2 parks, a children's park and a performance park, again with pavilions to the perimeter. And around the outside of the site, we had the usual backhouse facilities, a security road, and a small amount of parking. This is the final master plan we did for stage 3. As you see in the centre is the plaza. The lasers don't work, sorry. There's 3 petals, which are the themed pavilions, sustainability, opportunity, and mobility, which were buzzwords more than anything else. The 2 parks and the pavilions around the outside. The pavilions were a mix of commercial and country pavilions, so it'd be hired by places like companies like AutoCAD or by countries like Great Britain, New Zealand, to show off what they do. We have also the large area park around the site, which had shuttles taking the visitors to the 3 entry points, which are at the tips of each of the petals. As part of the deliverable, we had to prepare a level 3 BIM model, but there were some issues. There was no way we could do a Revit model, which none of us could use anyway, for such a large site. This is when our office in Dubai advised that they were planning on using Civil 3D. This kind of made sense to me because architects, structural engineers, M&E engineers all work in Revit and they all work in a common platform, but we don't work with any of them for what we do. We interface, but really we work more with civil engineering and highways and large-scale infrastructure. So using a common platform with them made a lot more sense. The only problem was we had no idea how to do a basic drawing, let alone an attributed BIM model, and Civil 3D wasn't really built to do one of those. Enter Chris Thorne and Jim Kelly, who had recently come to ACOM via our acquisition of URS. Chris and Jim are part of our digital delivery team, which is responsible for helping the various teams across EMEIA to develop their digital capability. Chris is a civil engineer with a long association with AutoCAD and Jim is a talented programmer who was going to make it all work for us. Jim and Chris sat down with me in our London office, a programmer, a civil engineer, and a landscape architect. Sounds like the opening of a bad joke. We spent an afternoon talking in circles, frequently misunderstanding what one another was saying, and having to backtrack a number of times as one decision broke another decision we'd made, often because we didn't know exactly what the other person was thinking. First, we had to work out what type of objects we'd use to create the model. An interesting conversation that confused Jim, as Chris and I used CAD technology, which he wasn't so familiar with. And then Chris and I got confused about points. For those of you, probably the landscape architects, Civil 3D has points and AutoCAD has points, but they're not the same thing. And that just confused me a whole lot until I realized that Chris was talking about something else. We then also had to look at a number of ways to include the data, including getting GIS software and servers involved, ArcGIS and that sort of stuff. I didn't understand a lot of that, so I let Jim and Chris deal with it because they seemed to know what they were talking about. In the end, it got really technical, and we had a lot of, well, if this is available, we might be able to do this, and that could work, and so we kind of peeled everything back from that and ended up going down a far simpler route. We finally agreed on an approach to leverage the AutoCAD architectural desktop property sets, which are included within AutoCAD, but not really activated, to apply data to surfaces, blocks, and feature lines, as well as a naming structure. We're going to use 3 letters to donate the product range, so PAV for paving, BOL for bollards, etc. And then 3 numbers after that, 001, 2 on onwards, to denote where it fell within that range. The data was then to be added in 2 spreadsheets. The first spreadsheet, a config file, would read the product type from the object. So at the start, we've got the different types, and add the property sets, which read the product type from the object and added the property sets to the object based on that's name. And then we had a specification file which showed the different products within each range. So this was our original sample file, so there's only a couple of products in there. And then that was the data that would get added to each set. Each line in the config file represented a product type: paving, trees, benches, bollards, curbs, etc. The types were categorized by what type of data we needed. This file could be office-wide. We wouldn't need it specific for each project because the data that you add to each product is going to stay the same on every product. Paving was all one category, regardless of whether it was natural stone or concrete, slabs or blocks, as that would all have still the same thickness, height, depth, the basic dimensions. But curbs had a different set of data that was required. The specification file has different sheets along the bottom, each named to match a config classification. Each of these sheets has an entry for each material or product of that type within the project. Hang on 2 seconds. That wasn't meant to happen. There's just more text that I can't see. And Jim was going to write a script which read these 2 files, added the data to the objects. We then went our separate ways. Jim to develop the script, me to work out the data to apply, and Chris to answer my stupid questions on Civil 3D. First thing I had to do was prepare a sample file for Jim to test on. I created a number of 3D surfaces named PAV 001, 002, 003, a line of bollards, BOL1, BOL2, and a pair of feature lines, KRB 001, KRB 002. I also created a basic config and spec Excel file, which was what we just saw, with the test data for each object. Testing went back and forth for a number of weeks before we had a working solution. At some point, we realized that feature lines aren't really going to work as curbs, because when you put them in, they worked fine on plan, but when you put them into a 3D model, you still just had a feature line. So we had to add solids into the script and into our data set. There's problems with that because solids don't, everything else we were using could be named. So the actual object, when you select it, had a name. But solids didn't take that. It's not a thing. So we had to start using the layer name. When we extracted the solids from the corridors, which we usually would use to make the solids, we had to make sure that they went onto the right layer. Eventually, we were able to add property sets and specification data to surfaces, solids, and blocks. This information was added in stages. First, adding the config data, which set out the first column. And then secondly, adding the data to adding the specification data. This wasn't a live process. If we added a new object, we had to run the script again to put the data back in there. It wasn't fast, but it also wasn't very hard. Once the background data and modeling was done, the data was added to the extended data tab of the properties window. Some data was automatically generated, which is really useful, such as the XYZ values of every object. So we could select any tree in the model and get its XYZ data because AutoCAD houses that for us. For discrete items, XYZ data. For surface finishes, paving, shrubs, bed, gravels, everything, anything we were representing with a surface, the area was calculated. We did run into an interesting issue where this was added into the area calculation instead of the area. It took us a while to figure that out. 2 instances of AutoCAD EXE running caused that problem. So we could only add the data when we had one instance. It didn't stay there. If I closed everything down and reopened the file with nothing else running, the area was calculated fine. So it didn't require running the script again, but when we were exporting, we had to make sure we only had the one file open. While work was being done on the script, my colleague Ulrich and I were working on a LOD LOI matrix. We were sent one from the client, which looked like that. A lot of tables and columns and pretty confusing for us. We had to fill it out and return it, but we'd not done this before. This was our first BIM model, and so we worked through it very carefully, but we had a lot of catching up to do. We worked through it, filling out which items we needed to provide, removing the items we weren't using. To aid us in this and help us tie this into our config and spec files, Ulrich simplified things a little and gave me one of these. This became very useful later on. It was only ever in-house, but it enabled me to begin final preparation of the spec and config files using the correct information. So we just kept updating this, and it would have been nice if we could have used something like this directly, but that's not the way it was structured at the time. So there was still a lot of manual back-of-house work. This was also supplied to the spec writers, who requested an additional column to tie the product to the specification. Our preference was to use the Bim code, the PAV01, PAV02, that we were using, because then we only had one code. However, politics intervened. Our specification team create for every project what they call a T-sheet, which lists all the objects and where you can find it in the specification. And it's also referred to on the drawing. So on your drawing, when you do your detail for the product, you put the T-sheet, it refers to the spec, tells you where to look. They've been doing this for a number of years, and they have an established protocol for naming, which was didn't really work for us. All their softworks were EXS, all their hardworks were EXH. That didn't work because that would have meant that curbs, paving, and everything had to have the same fields of data applied if we'd used that. So we had to just put in an extra column. I don't know if it's sitting in there. No. We had to chuck in an extra column with the T-sheet code, and that became an extra reference. So everything ended up being double-coded, which we weren't really happy about, but specification writers, they wouldn't change their mind. We also did a model reference for the client, so we could set their expectations for how the model would look. This is an early one. We had to go through and change the color of some stuff and make it look a little bit more different. So the client wasn't looking for a photorealistic model, fortunately. So we categorized everything by color. So all bollards were one color, all paving was another color, which wasn't on this particular copy. At one point, the client asked us to change our 3D trees to the cross plane that's shown there from Revit. We thought that because we wanted to use clash detection. And in our mind, that tree you can't clash detect, because if you've got a pole running through your canopy, it's going to miss those planes, or it might miss those planes, and suddenly you're not getting real information. That's one of the few fights we did win with the client. We also added the Bim Execution Plan. We also added to the Bim Execution Plan a workflow chart to help mitigate client expectations. They were used to dealing with architects and who were working in Revit, where they could just take the current model they were doing, chuck it out, and they'd be able to see where they're at any point. we weren't working like that. I had a few conference calls with members of the project management team to run them through how we were working and why we couldn't just produce a working model. The structure above is simplified. There were there were a lot more files in the end, but basically we were working like this. Our designers were still doing 2D drawings, as we've always done. This was for stage 3. There was, as this was for stage 3, there was a lot of design revisions, a lot of change going on constantly. So I withheld trying to get them to use Civil 3D, which I would have had to teach them anyway, to create some of the elements, because it would have just been abortive work, and it would have taken far too much time. As far as the BIM model was concerned, the two most important parts of what they were doing was the hatch boundaries and the blocks, which I will cover shortly. While the team were designing the site and drawing up the plans, I was working on a full site model, making corridors and surfaces for the things that were fixed. The 3 large pedals and all the concourses, their alignment wasn't changing and their grading wasn't changing, or at least not from the designers, but more from my interface with the civil engineers. So we set out those, drew those, modeled those in 3D, which was the first I'd done, and then we were able to work with the civil engineers to send them our live data, because they're also in Civil 3D. We were able to exchange the raw data and use it all. Once the design was complete and submitted, we took all the hatch boundaries and we created a new Civil 3D file and brought in all of the surfaces that were relevant to that particular area as a data shortcut. We then pasted the shortcut surfaces into a number of surfaces, each one named for a different material, and we used clipping boundaries to clip them all. I'll go over this a little bit more as we go, but at the same time we also brought in all the blocks, the trees, the signage, the furniture, the lighting, and elevated them all to surface and applied the data. They were the easiest part of the whole lot. Finally, the script was run, put the data on all the objects, and we exported them into Navisworks and compiled our file. I will go into this a little bit more. Finally, so that was just jumping ahead a bit, but after we'd done the basic scripts and worked out the script and stuff, I had the fun job of learning Civil 3D, which for me actually isn't sarcasm. I really like CAD, I really like learning new stuff like this, so I was kind of in my element, and I was given a bit of free rein and a bit of time to do it, which is often rare for these kind of things. I spent a lot of time working through tutorials, talking to Chris, and learning how to create corridors, solids, custom sub-assemblies, and surfaces. I was working out how we could utilize these to produce both our drawings and our BIM model. We decided to use surfaces for our surface finishes. Sounds obvious. Predominantly paving, asphalt, gravels, and planting. Shrub planting, low ground covers. All the trees were blocks. We were creating these in a combination of corridors, feature lines, and polylines. The civil engineers were preparing corridors for the concourses because ultimately it was their responsibility. So we were able to take their alignments and profiles. However, they looped around short of the central plaza, as you see there, because they were designing the legacy road system. So Chris had to show me how we could combine two sets of alignments. So I took their alignment up to the point where it broke, and then I added on a new profile on there for us. It's worked pretty well, and it's still a manual process. If there's changes, I got to go in and change it. But it sort of seemed to be the best way, because we're using data shortcuts. When they send me updated data, I can just overwrite the old stuff. I get their new profiles. I then just change mine to suit. To avoid having pedestrian crossing the busy perimeter roads, the arrivals plazas were set 7.5 meters high in the perimeter boulevard, leaving us with large sections of walls. To model these, we used 2 custom sub-assemblies, one which replicated the high retaining wall and one which we used for stepped gabion walls. At this point is where I learnt to do targeted corridors, adding top and bottom profiles to the retaining walls and offsetting gabion walls. So these were the sub-assemblies we did up. This was all extracted as a solid, and as we said, solids can't be named, so when we extracted them out, we had to make sure we used the right layer. In addition to working on our BIM model, I was sitting with the lighting and signage consultants. We had to deliver a BIM model for their packages as well, but they aren't using Civil 3D, and it really wasn't practical for them. In a normal package, their items would be represented in 2D using standard blocks. I'd been figuring out multi-view blocks by this point and was already setting them up for trees and furniture for our team to use. Who's familiar with multi-view blocks? Or who isn't is probably a better question. I'll just cover it really quick. Essentially, a multi-view block has 4 parts. You have 2 standard blocks. One contains a 3D model and one contains a 2D model. So I laid out this for them. So the top one's the 3D model. The second one, I think they both say 3D because I had screwed it up. The second one's the 2D model. Then the next one down is the multi-view block itself, which is a special, I think it's only Civil 3D. It might be also Architecture Desktop. It is not in standard CAD. That block references those 2 models, and you then house that inside a standard block, which can be worked, manipulated, counted as a standard block. But when you go into 3D, alright, wait. That's weird. There's supposed to be another slide there showing it. It's not showing up. But when you go into 3D, you see the 3D block, which essentially, I'll keep going because there's one in a minute. Our sub-consultants weren't using Civil 3D, so I set up a file with them, which is this one, with a number of placeholder blocks split into the 4 parts. They were then able to edit the top 2 and to edit the 2D and 3D component, which they were already modeling for their detail packages anyway, and rename the final combined block to work with our script. It took a few visits to their office to rename the naming issues, but it didn't add a huge amount of work to the process, and they took the 3D models they were already doing anyway. For the lighting and signage that was mounted to the canopy, which we weren't designing, we elevated the 3D model within the block to the height it would be off the ground, so that when we elevated to the surface of the model, it was then sitting 10, 12 meters up from there. We were able to use the multi-view blocks within our drawing package. The lighting and signage design is referenced in our drawings referenced our landscape and master plan drawings, and then prepared their drawings over the top, which we then referenced into ours. All of the teams were working within ProjectWise, allowing us to reference the live drawings, ensuring we were all working with the latest information. This meant the same drawings were produced for the CAD package were produced for the BIM model, something our client was really keen on us doing. We then used Elevate to Surface to bring all the blocks to our design levels. Those that were ground level sat on the surface, those that were canopy mounted floated the correct height off the ground. Skipping forwards a bit, after all the drawing was done and we prepared our final model, it was really exciting for me to open the model in Navisworks and see the signage hanging between the canopy columns. It makes sense that it all worked, but it was just really reassuring that we got it right. So the purple one there, its insertion point in CAD is at the base of the blue columns. Same for the 4 cluster lights around the top. And it's just that we elevate it to the surface of the model. They are all in 3D space. So we added a property to those elements just to say how far they're off the ground within the data, so that it didn't, because the XYZ value would be returned incorrectly. A lot of the initial work on the model was done by me, learning as I went, while everyone else was designing. I had to get the site surface finished early, as other disciplines, particularly the civil engineers, needed the site levels to do their work. I also took this time to work out how to extract solids, set the targets on the corridors, and test the script, which was working pretty well. I did ask for a way to cancel halfway through the command though, as a few thousand objects in the planting plan, an error required some creative office engineering to exit. Once our team had submitted the DD package, we had 2 weeks to prepare and submit our BIM model. I was given a lot of the staff who'd worked on the drawings and the report, so I did a 2-hour workshop in the morning running through how to do corridors, feature lines and surfaces. Sort of the basics. Half of them were set to cutting up the surfaces. We used the hatch boundaries I mentioned earlier from the material plans, which highlighted how important it is to have good closed single polylines. When the guys had been doing the hatch boundaries, I had asked them to put them on the layer. They knew the naming convention, so it was a case of just copying and pasting them in. The others were set to modeling the arrivals plazas. I'd set a framework up, but last minute design changes necessitated updating them. This included the gabion walls, which were shown earlier, which was a good lesson for the team. They managed to do a good job modeling these up, and many of the surfaces were worked off dynamically linked feature lines. So as they updated the walls and stuff, the surfaces updated to pick that up. I'd set the structure of the site up with data shortcuts, so the team that were cutting the surfaces up just got the surfaces at the new level without having to worry about re-importing data. One of the designers, Christina, and I took up the final and most complex part, the performance part. The only one we were doing at this stage had been designed in Rhino and drawn up in AutoCAD for the drawing package. We weren't able to use the Rhino model as the script didn't read that data properly. A Rhino surface is different from a Civil 3D surface. And it was also modeled with a flat elevation, whereas this site was modeled based on the perimeter boundaries of the corridors that were adjacent. This meant we had to rebuild the entire park in Civil 3D. Christina hadn't ever used it before, and it required a change of mindset for her to adapt to the modeling style I'd used. We had a few arguments over a few different things, and of course the design wasn't simple, with lots of low levels, steps, walls, sloping walls, and sunken oases. Starting with a blank surface generated from the corridor feature lines, we modeled the steps to the sunken oases, which are these three here. This allowed for the nice, we run the corridors along the steps, so that, and then we modeled the steps in the assembly. This allowed us to have the nice sweeping steps going down. This is a technique we carried through for the rest of the park. Curbs and low walls were custom sub-assemblies, as were the railings and parapets to the cafe. We had the railings back here as well as railings running across the top. It's all done by a single assembly. We were able to, the sloping lawns that we used were modeled using a plane set at the right angle with a draped feature line over the top, which we then created a new surface from. We were able to bring in solids for the planters directly from Rhino, although there were some issues with size, and I think you can see some of them on there. There's still gaps and black areas underneath. Which we will need to resolve more carefully next time. The script reads the solids the same as the solids extracted from the corridor. So as long as we got those on the right layer, they could take attribute data. The final part of the model was the addition of the attribute data. By this stage, we'd prepare fields for all the products. So this is our final furniture. No, that's our final config file. So that's the number of product types that we were using. The script had been tested extensively and worked well, but user errors still crept in with typos in the spec file, causing it to fail. We had some limitations on special characters within the fields, but I just got a bad habit of typing what I know should be there. And so I had a lot of time, again, with the stapler on the escape key. For future submissions, I do intend to split the landscape spec file. Do I have that? Yeah. Into a number of smaller files, because the amount of data stored within it meant it took a long time to load and run than the smaller lighting and signage files. This data doesn't have to be in one file, although it's easier if you're running everything for one model is in one file. But we didn't do furniture in the same file as we did our benches. We broke it all up, so we could have split all of that out. Somewhere during these few weeks, we were also asked to provide every object with a unique ID. AutoCAD-based software does add an ID to every object, however, it's only unique to the drawing. And if you copy the object between the drawings, it'll give it a new ID, and you can get duplications across the drawings. As we're compiling a large number of drawings together, we needed to append the file name, which was unique to the project, to the handle ID from AutoCAD, giving us the unique ID for each object. Once we added the data, we exported the data from Civil 3D using NWC Exporter. We had originally simply appended the DWG files to the NWF file, but we found the automatic data fields, especially the area, didn't come through as they were read and filled out live by Civil 3D. Navisworks didn't pick that information up. Exporting the data fixed that issue as the data was written to the property tab and not read from the object. Combining our completed data in Navisworks for the first time, as shown earlier, was exciting for us. Seeing the various disciplines and elements fall into place correctly made all the work we put in setting it up. So that's the arrivals plaza with the bridge over the top and the railings and the walls. The areas that are black are where the civil engineers' roads would sit. That's the park, which was the final model. This was the last piece done, and probably the bit I'm most proud of, just due to the complexity of the area. And then we have some of the data. So the data showed up on a separate tab The only problem was we added the ACOM ID as a separate property set, which means it comes up on a separate tab. It was easier at the time, but we may have to look at tying it in because when the guys export the data, they had to export 2 different tabs. The other issue they had is the name of the tab, the ACOM attributes TRE, that's read from the property set name, and we couldn't have the same property set name for the different materials, meaning that when the guys were exporting for quantity counts and stuff, they had to export separate ones and they got separate tables and stuff. They asked us to take that bit off and just have ACOM attributes, but unfortunately we couldn't do it. So it's sort of a challenge to overcome. But we had the data showing up where it was supposed to be, and the model looked pretty good for a working model. We still had some holes in it, but for our first attempt at a model, and being for developed design, we were really happy with it. That's the final paving and furniture. Once we submitted the model, our team in the UAE had to prepare a quantity takeoff from the model. Unfortunately, as ever, this was never as straightforward as exporting all the information. Due to the size of the site and the fact it was being converted into housing after the event, the public areas had been divided into separate plots. The client wanted the takeoff to be separated into each of these plots. We had 2 options. We could either split all the surfaces up when we created the model, creating potentially hundreds of surfaces, or the GIS team could take our information and break it down. We did offer them the first option, but fortunately for us, they said they'll take responsibility. The takeoff for the blocks was really simple. They were able to load them into GIS along with a subdivision plan and pull the quantities out for each plot easily. Signage, trees, furniture, all done pretty quick. Then we got to paving and other surfaces. The GIS software wouldn't read the surfaces directly, so we had to work with the polylines that we used to split the surface model up into different materials. Into the second lesson we had on the accuracy needed in the production of polylines that we used to do this. There isn't much in the way of imagery to show you for this section, but I got a lot of emails like this, and this, and this, all complaining about the areas that weren't working. This is just a nice night shot. I couldn't find an appropriate place to put it, but I wanted to use it. So I'll let that distract you while I finish up the rest of this. The GIS guys did a comparison of the GIS output with the BIM model and found significant numbers of differences. We had to run through every single file and every single surface to find out where the issues were. There were 3 reasons. Sometimes we had duplicated boundaries, so the guys doing the hatch patterns had put 2 boundaries over top of each other. This wasn't a problem for the Civil 3D because it just applied them and clipped to both boundaries, and you add a boundary as a clip or a show or a hide, so it just treated it as that. However, in GIS it counted both of them, so it doubled the size of a lot of areas. The second problem is some of the polylines weren't closed or had self-intersecting elements. We found this mostly on the complex surfaces, which had many small areas of material, meaning we didn't notice if a hole or 2 had been missing. The larger ones we found because there was a big gap. Self-intersecting polylines didn't apply to the surfaces either, but GIS counted them, meaning a number of surfaces were also too small. Finally, we had user error. We'd set up the layer system for cutting the polylines where the layers were on the pavement name or the material name, and then where we had to have boundaries which cut holes, so show or hide, we had to have them separated onto 2 different ones so that the GIS guys knew to subtract that one or put that one in. However, with 5 people doing the splitting, also the guys who'd done the hatching, most having not used Civil 3D before, there were some objects on the wrong layers or with the wrong name, or also they just weren't on whether they hadn't been split into show or hide. This all highlighted for us the need for a more rigorous Q&A process and what things we needed to look for at the next stage. As happy as we were with the final model, we did still have significant hurdles to jump before this becomes a more commonly used within the team. The first problem is getting users upskilled on Civil 3D. We have some good people in the team, but unless they're regularly using it, the skills go to waste. I'm running classes once a week to teach them the basics, and it's only the basics because that's all I know, and I'm about a week ahead of them at times. Hopefully we can start using this more on projects, and the issue will reduce as we move from that to from AutoCAD to Civil 3D. The familiarity with the software will also hopefully help us model more efficiently. I'm sure there's many things we did which would make an experienced user cry. Another major issue was managing client expectation. As I highlighted earlier, the client was used to working on large buildings, expecting us to be able to do regular data drops. we weren't using Civil 3D like that. We were still mostly working 2D and converting it to 3D. We did prepare a flowchart for the client, which I showed earlier to explain the process. That got us a lot of leeway. For the next step, I hope that we can have more Civil 3D stuff on our production drawings so that the top of walls, the curb lines and stuff are coming out of our Civil 3D model. And that way, it's a lot more live and we can slowly move into getting a lot more accurate modeling. Some more technical problems we had included modeling using solids. As I highlighted earlier, we had two issues. Things with like walls and fences and railings, they were modeled using corridor solids. First, we were using 2016 and they weren't dynamically linked, leaving us to export the corridor, export the solid multiple times if the corridor changes. Secondly, there's no automatic way to generate the length of a wall from a solid. So we had to go around and manually check the chainage length of every wall and provide that just in a spreadsheet. We looked at the possibility of slipping in a formula that will calculate that based on volume and cross-section. However, a lot of our walls had reducing heights and bottoms, so that doesn't really work so well. This has the potential to be a future issue if we decide to start modeling build-ups for paving as solids rather than as a straight surface, as that'll no longer give us the area of paving, it'll just give us the volume. Civil 3D 2017 has some solutions for this, especially now that dynamics are solidly linked. Solids are dynamically linked, meaning that if we move the wall, the solid moves with it. That fixes the first problem, and you can also now put the chainage into the layer name, so we're hoping to be able to use that to extract the length. The other one is dynamic updating. As we were using 2D polylines to cut our surfaces, which were our hatch boundaries copied from another file, we weren't able to have the model dynamically updating with the hatches. As we move forward, hopefully we can use more Civil 3D elements, feature lines, which will to be part of the package as the blocks were, so that our model and our drawings align better. This should help reduce the stress during the 2 weeks I had after the drawing submission when we convert all the information over to the BIM model. We still have a way to go before we use this frequently, but we are starting to use Civil 3D at least more. We've got a stadium in Cameroon where we're using that to do all the contouring and modeling, and it's made a huge difference. I've done contouring for 13 years now, and I've always done it by hand, drawing polylines over and over again, and at least now I know I can do the cut and fill calculations accurately. That's it, but if anyone's got any questions, I've got the BIM model here just as a Navisworks file which we can pull up, and I can answer any questions you guys have.
There was somewhere mentioned in the B plan, if I'm not mistaken, that you used the InfoWorks.
Sorry, can you speak up a little?
There was more mentioned somewhere in the BIM management plan that InfoWorks was used.
We had looked at InfoWorks and we were using it originally, and then we couldn't figure out how it was helping us. And the BIM coordinator, who we swapped BIM coordinators, and he came on and said that for the way we're working, we just want to be using Navisworks. The original plan had been not to use Navisworks and to use InfoWorks instead, but it's all three pieces of software were brand new to us, and we were just doing what we were told, and then someone came on and told us to do something different, so we swapped.
Okay, firstly, very impressive model. Well
Thanks.
done. It's very complex. I'm quite interested in the property set data.
Yeah.
For that, did you have to manually create each field for the property set data, or did you manage to automate that?
So Jim Kelly wrote a script. So the config file set the fields for each surface type, and then Jim got that automatically created via the script, and then the data automatically applied via the script as well. So we did it in the Excel spreadsheets. And
so you had the Excel, you had your data fields in Excel, but for the property set data, you know when you go in and you create a property set data, initially it has got no fields.
Yep.
Did you have to manually create?
Nope. No, the script Jim created added all of that in there for us. So yeah.
Okay, I've looked at that, and I've looked at all the forums, and I could not
I
see a
couldn't.
solution. So I'm really, really impressed with that.
Yeah, I don't know huge, like that was all new to me. But yeah, Jim he's worked with AutoCAD, he does testing for us for years. And so it's one of them things where I'm just blown away by what he can do.
And the second question, which is kind of closely associated, you were talking about the unique ID and the fact that it loses the entity handle, which I'm very familiar with. Did you program that as well to add on that new field?
We did that one manually, the way you were just saying, because it was, I created it once, and then I copied and pasted an object with it, I think, or I copied and pasted it between drawings somehow. I can't actually remember how now. I think you can copy and paste the fields from one drawing to another. And then I just selected everything and applied it to them manually. So that one was more manual. I think next round, I want to get Jim to tell me how to add that as a field, which it should be able to, because we're able to add in automatically adding fields. So there's no reason that can't be put in there. It's just got to be done. Like, I just got to get Jim to show me how.
Okay, thank you.
Yeah.
You mentioned that you passed the model to GIS.
Yeah.
Did you go through a conversion process, or?
I don't know a huge amount of that process. I think what they did, I think they worked from our DWGs, and because they didn't use the Civil 3D data so much as they used the AutoCAD data. So they had a subdivision plan, which was all just 2D polylines in CAD, and they had our polylines, which we'd used to clip clip all the surfaces. So I don't think they used the model. I think they opened the model in Navisworks, and they opened their GIS data, and they did a manual comparison to make sure they had it right. But they didn't use the data natively. I don't think. But with the blocks and stuff, they just opened the CAD file in GIS.
So that was 2D GIS?
Yeah, I think so. I'm not actually sure, but everything that came out of it, I think, was 2D.
Okay, thank you.
There was one down here.
Yeah, I'm just a bit curious about the script. Do you know what language was it written in?
I couldn't tell you that at all. I have absolutely no idea.
Do you have like a screenshot here we can see?
No, I don't even know where it is on my computer. Jim just hacks in when I'm not at the office. He's like, I've got an update for you. I was like, okay, and I just go and get a cup of tea. Yeah. And then I come back and he's done it. So unfortunately,
you didn't run it. He did that. He ran the script for you.
He wrote the whole script. Yeah, it's an ACOM based one. Like, so I can't even run it. Like, I can't put it on my computer at home or anything like that, because whenever you start it, it looks for an ACOM server. It's real sneaky. If I'm not connected to the network, I can't use it. It's really frustrating.
Yeah, but is it that thing there? There's a button says scripter. Is it?
No, this is Navisworks. So I don't know what this does. Yeah, sorry, I've just popped up Navisworks now. So this is our final Navisworks model.
Yeah.
So yeah, unfortunately, I can't give you any information on the inner workings of the script. I can tell you what it does and who wrote it.
But do you know how to run it from?
Yeah, so within AutoCAD, I mean, it probably doesn't tell you anything, but it's just a keyboard command. It pops up a dialog box. I pick the config file and I pick the specification file, and I hit a big button that says apply to surfaces, or I pick a button that says apply to blocks, and it's as simple as that. It's not fast because it's got to read all that data, and then obviously the lighting and signage were hundreds of blocks, so it took a long time to run, but it wasn't complex from my end for the user experience. At first it was. Jim did refine the user interface a little bit to make it easier for me, but yeah, it's all custom written, and we're wanting to talk to AutoCAD, and I'm going to have a chat with the guys at the back there later on about trying to see if we can get some of the stuff in there, because it makes sense from our point of view. This is where we see the future for landscape architecture, and obviously, if we can get this running, it's going to benefit all of the civil engineers and everybody else as well. So we would like to have a chat with them about trying to get some of this information natively into the software, given that it's already there. It's just we need that connection to be made.
Yeah, that's great.
Yeah.
Yeah,
Yeah,
thank you.
which makes your lives easier as well.
Thanks.
Anyone else? Cool. Okay, thanks very much.